Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are still on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a question. In this video, we are going to apply the trigonometric ratios and the Pythagoras theorem to solve another question. So let's look at our question for this video. Consider the diagram below and find x and y. Find the length DC. Give your answer in 3 significant figures. So this is the diagram. We have to consider it and find x and y, then we find the length DC. Now, considering this diagram very carefully, we can see that there are 2 right-angled triangles. The first one is ABC. So triangle ABC is a right-angled triangle. Then triangle DBC is also another right-angled triangle. So we have one right-angled triangle inside another right-angled triangle. The question says that we should find x, that is the length AB, and we should find y, that is the length AD. Then we should find the length DC. So we are going to solve it one after the other. So let's pick the first one, which is the length AB. Now we can see that the length AB is the length x is in the right angle triangle ABC. So we are first going to consider triangle ABC alone. So from triangle ABC, this is triangle ABC, ABC. We can see that the angle here is 40 degrees as we have here. The length BC is 30 meters as we have here, 30 meters. And the length AB is x as we have here, x. Considering this triangle, we can see that x is opposite to 40 degrees and 30 meters is adjacent to 40 degrees. So we have the acute angle here, which is 40 degrees. We have x as opposite to it, and we have 30 meters as adjacent to it. So we have opposite, we have adjacent. Which trig ratio should we use? We are going to use tan because tan is opposite over adjacent. So we can say that from this right angle triangle, tan 40 degrees is equal to opposite, which is x, divided by adjacent, which is 30 meters. Okay, so from here, we can simplify this equation and find x. I'm going to multiply the left-hand side by 30. Then I'll multiply the right-hand side by 30. When I do that, you see that 30 will cancel 30. So we have 30 times tan 40 degrees is equal to x. 30 times tan 40 degrees will give us 25.2 meters. So if you do this and you correct your answer to 3 significant figures, you have 25.2 meters. I explained how to correct a number to a given significant figure in the videos on approximations. And I also explained how to use your calculator to do that. So if you watch that video, you know how to correct a number to a given significant figures. So 30 times tan 40 corrected to 3 significant figures is 25.2 meters. So x is 25.2 meters. Let's move on to y. You can see that y is in the bigger triangle. That's triangle DBC. So if you want to find y, you have to consider triangle DBC. Okay, so considering triangle DBC, you see that this angle here will be the 20 degrees here plus the 40 degrees here, and that will give us 60 degrees. So the angle formed at C will be 20 degrees plus 40 degrees, that will be 60 degrees. The length DB or BD will be AB, which is x, plus AD, which is y. So the length BD or DB is x plus y. and so the length BC is 30 meters, as it can be seen here. So on this triangle too, we can see that x plus y is opposite to 60 degrees and 30 meters is adjacent to 60 degrees. So we have opposite, we have adjacent. So we are going to use tan. So we say that tan 60 degrees is equal to opposite, which is x plus y, divided by adjacent, which is 30 meters. Okay, so we have our equation here. So let's solve it. I'll multiply the left hand side by 30. I'll multiply the right hand side by 30, so that this 30 and that 30 will cancel. So 30 plus tan 60 degrees is equal to x plus y. 30 plus tan 60 degrees corrected to 3 significant figures is 52.0 meters. So we have x plus y. But don't forget that in the previous slide, we found the value of x. So we know that 50.0 is equal to x plus y. But we have found the value of x to be 25.2. So we can change x to 25.2 and find y. So we have 52.0 is equal to 25.2 plus y, because x is now 25.2. So 52.0 is equal to 25.2 plus y. If you make y the subject, you have 52.0 minus 25.2 is equal to y. And this will give us 26.8 meters. So you see that you have been able to find x to be 25.2 meters and y to be 26.8 meters. So using the trigonometric ratios, we have been able to find x to be 25.2 meters and y to be 26.8 meters. We've answered the first part of our question. It said we should find x and y, and we have done that. The second part of our question said we should find DC, the length DC. Okay, so that is exactly what we are going to do. Now you can see that the length DC is in the bigger triangle. So it is in triangle DBC. Okay, so you are going to consider triangle DBC. But look at something. We now know x, we now know y. So we can say that the length BD, so x is equal to 25.2 meters and y is equal to 26.8 meters. So the length BD is equal to x plus y. X plus y will give us 25.2 meters plus 26.8 meters, and that will give us 52 meters. So we know the length BC to be 30 meters and the length BD to be 52 meters. Okay, so if you are considering triangle DBC, we know that the angle here is 60 degrees. We know this length to be 30 meters. We know this length to be 52 meters. And we want the length DC. That's what the question told us to find. So this is a right angle triangle. We know BC to be 30 meters. We know BD to be 52 meters. And we want DC, which is the hypotenuse. We can apply the Pythagoras theorem. If you apply the Pythagoras theorem on this right angle triangle, you will see that DC, which is the hypotenuse, DC squared is equal to BC squared plus BD squared. We are looking for DC. So DC is equal to, BC is 30 meters, so 30 squared, plus BD, which is 52, so 52 meters, so 52 squared. So let's solve our equation. We will have DC squared is equal to 30 squared is 900, 52 squared is 2704. We add this, you are going to have DC squared is equal to 3604. We take square root of both sides. Correct your answer to 3 significant figures, and DC is equal to 60.0 meters. So using the Pythagoras theorem and the trigonometric ratios, we have been able to find x, y, and the length DC. Thank you for watching this video. I hope you enjoyed the video. If you did, don't forget to like and subscribe to this channel. In the next video, we are going to apply the Pythagoras theorem and the trigonometric ratios to solve another question. Bye-bye.